Hello everyone, welcome to the 7th tutorial class on artificial intelligence. This class is basically continuation of earlier classes of genetic algorithm. So this is the second part of genetic algorithm. In earlier class, we have already discussed about the operation of basic genetic algorithm, and we have also observed the corresponding flowchart of GA. GA is basically a optimization technique which is inspired by the theorem of Darwin, that is the survival of fittest. During the evolutionary process, the solution or the population gradually moved to the optimal point by using different operator like selection, crossover, mutation. So, in this class, we will discuss about the three important operator of GA, which is required to understand with more clarity. So, in this class, we will discuss the detailed explanation of selection, crossover, and mutation, how they operate. And at the end, we'll uh, give an example of optimization problem that can be optimized using GA. It will helpful for us to understand the GA with better clarity. Now, moving to the next slide, before discussing about the parameter operator of genetic algorithm, let's revise the concept of GA. So this is basically the figure that describes the general scheme or operation of evolutionary process for GA. So as you already know that genetic algorithm is started with the initialization of population. Population is similar to the chromosome for the biological concept of genetics. So population consists of solution for a particular optimization problem in computer science. Now from that population we need to select two parents which are more significant, and this significance can be determined by the fitness value of the corresponding solution. So from the population we need to select two parents. Okay, now next part, so that now the important sorry, now the importance of this selecting these parents are that we need to intermingle, or we need to mate with the parents so that they can the new child or new offspring can be generated. So after the selection of parents, two operator has been applied, that is the recombination, and next one is the mutation. In recombination process, the characteristic of two parents has been interchanged, and during the mutation process new characteristic has been incorporated in the parents, and after that we get the resulting offspring or resulting child. And if the fitness value of the resulting child or offspring, or you can say that new solution, is greater than the parents or earlier solution, it will become survive, and will incorporate this new solution or this new offspring into the population, and this process will be continued until termination criteria has been reached. So this is the way we can reach the optimal point for a particular optimization problem. So initialization, selection, recombination, mutation, and accepting, and after that we need to terminate the total whole program. So this is the basic operation of GA, and you can see that this is the pseudo code of genetic algorithm. So first of all, initialize the population with random candidate solution. We don't know about the what is the probable candidate solution? We just randomly randomly generate some solution. Then we need to evaluate each solution so that we can calculate the we can we need to know the corresponding fitness value of the each solution now, which is required for the selection purpose. Okay, now we continue a loop where it is written as like this: repeat until termination condition has been reached, and reach do loop. And first of all, select the parents. Now select the more selection is based on the fitness value. The parents which have the more fitness, there will be more probability to select them as parents. And after that, after selecting those parents, we need to recombine pair of the parents. Now after that, those recom and after the recombination, one offspring will be generated, offsprings will be generated, or children will be generated. And next we apply the mutation where new characteristic or some value can be changed in the resulting offspring. And after that, we again select the uh, resulting offspring and uh, move to the next generation. And this process will be continued until the termination condition has been reached. Okay, now, as we already told, three important operators are selection, recombination, mutation. Re- we can call it reproduction. Selection and reproduction are the synonymous, and crossover and recombination are also synonymous. Moreover, there are others two parameter. First of all, there is you can control in the during the simulation. First of all, the population size, that means the number of initial solution or the number of chromosome. And after that, you can also control the iteration number, that means how many number of loop you want to continued. So these two parameters can be also controlled, but however in this lecture we will discuss only main three operator, that is analogous to our natural world of genetics, which are reproduction, crossover and mutation. Okay, these operator are basically needed for the to maintain the genetic diversity, that means to maintain the process of evolution. Until unless we don't apply these operator, that means selection, crossover and mutation, the chromosome or the solution or the population will not be evolved, and we don't get the better solution, or new generation cannot be reached, new generation cannot be generated. Okay, now coming to the first operator, that is the selection. We can also call it as reproduction. And so what is selection? So selection is nothing but the selection of chromosome from the pool of the existing population. Okay, so you can say that as according to the Darwin's evolution theory, survival of the fittest, the best one should survive and create new offspring. Okay, so based on that fact, we can apply, or you can use selection operator where we want to extract a subset of genes which are called as parents gene from an existing population according to the definition of quality. That means based on their fitness value, we need to select subset of genes or a pair of genes as parents so that they can intermingle or they can mate with each other. Okay, so every gene has a meaning. That means every genes or every chromosomes has its fitness, own fitness. Okay, now that is so that indicate the quality of the quality of the corresponding solution. Okay, so based on that fitness we should select. Now for that selection, for the selection, there are lots of process has been already proposed, like rattle wheel selection, Boltzmann selection, tournament selection, rank selection, steady state selection. Among them, most popular and simple is the rattle wheel selection, and we will discuss the rattle wheel selection in these classes. Okay, and if you want to know about the other selection, you can go through the internet or others book. Okay, so basically all these operators essentially do the same thing. Okay, that means they pick from the current population based on their fitness value. Okay, so that we can process the, or we can apply the crossover and mutation operation on them. Okay, now uh, let's discuss about the router wheel selection with an example so that we can understand with more clarity. Okay, so consider an optimization problem, that is we want to maximize fx equal to x square, and the range or the interval of the x is between 0 to 31. So if the value of x can be varied within the 0 and 31, and from that interval we want to know the what is the value of the maximum function fx equal to x square. Okay, so it is very simple. By just observing the function, you can tell that maximum function will maximum value of the function fx will be 31 square. But for our part, optimization problem, we want to want to know the maximum value of this function using GA. Okay, so the coming to the application of GA for this particular problem. First of all, what we have to do, we need to do the encoding. That means whenever we want to generate some random solution, okay, some random solution, so we need to first of all determine the encoding process. You can see that the value of x is varied from 0 to 31. That means if you want to encode them, that means encode the value of x, that means we need minimum 5 number of bits to encode into the binary number. So first of all, 5 bits are used to represent the integer up to 31. So you need to first determine that. Okay, now next consider the population size. We are already telling that population size can be controlled. Okay, we are assuming for easiness that the population size is 4. That means 4 number of solution will be generated randomly. Okay, so the random chromosome or random genes are like this: 0 1 1 0 1 1 1 0 0 0 1 0 0 1 0 0 1 1. Okay, so these are the random number. Okay, now now so first of all, initialization part has been completed. Now second part, that means selection part. So for the selection process, as we already told, selection is based on their fitness. So first of all, we need to identify their significant their value, their significance of that particular solution, that in term of fitness. So first of all, decode them. Okay, so 0 1 0 1 is corresponding to the 13, 1 1 0 0 corresponding to 24, 8 1 0 0 corresponding to 8, and 1 0 0 corresponding to 19. Okay, now for this particular decimal number, what will be the value of fitness? And we already know the corresponding function has been given, that is fx equal to x square. So for the solution, first chromosome, the value is 169, and for the second one 576, for the third one 8 square, that is 64. The next one is the 19 square, that is 3361. Now, coming to the next part, that is mean based on that fitness value, we need to get we need to select parents. Okay, so for for this purpose, we need to use router wheel selection process, where there is a probability of selecting a particular solution. Okay, so solution for sorry, so the probability for a particular ith solution is fi divided by summation of j equal to j equal to 1 up to n fj. Okay, where fi is the fitness for the current ith population, and pi is the probability of string I or population I selected, and n is the total number of individual in the population. Here n equal to 4, and n equal sorry. Okay, so if we calculate this probability, if we calculate this, we will get the corresponding probability of selection. Okay, and last one is has been given that if we multiply this probability of selecting population pi with the n that will be given by expected count. Okay. So here you can see that corresponding table. So string 1, that means chromosome 1, chromosome 2, 3, 4. Okay, and the initial solution has been given, and corresponding decoded value of x like 13, 24, 8, 19, and corresponding fitness fi has been given 169, 576, 361. Okay, now applying the corresponding Routel-Hale selection selection process to calculate the corresponding probability, where you can see that probability for the selecting chromosome 1 will be 1 will be, what is the formula, fi divided by summation of fj. So you can see the total sum is 1170. Okay, so the probability for selecting chromosome 1 will be 169 divided by 1170, that is 0.14. So for second one, 576 divided by 1170, that is 0.49. 64 similarly. Okay, so you can see that for four number of solution, the corresponding probability are 0.14, 0.49, 0.06, and 0.31. Okay, and if you sum up them, then obviously total probability will be 1. Obviously, among these probability, it is very clear that the selection of second solution, sorry, the chance of selection of second solution is highest. Okay, and you can, next one is the expected count, that is the in multiplied by pi. So if we multiplied 4 with the 0.14, we can get that this value. Okay, so ultimately second solution will be selected as one parent, and based on this probability, any other solution can be selected as other parents. Okay, so this is the selection process where we apply Routel wheel Rowlet wheel selection process. Okay, I think the process is very clear to all of you. Okay, now coming to the second operator, which is the crossover. So crossover is a genetic operator that combine two chromosome to produce a new chromosome, where where the characteristic of each parents will remain in the new chromosome or offspring. And the idea behind this crossover is that it is possible that new chromosome may be better than the better than the better their parents chromosome. Okay, so crossover occurs during the evolution according to the user definable crossover probability. That means it that is how the crossover will be crossover will happen. Okay, so that should be defined by the user. Okay, now there are different operator. First one of the simple operator is 1 point crossover, and the others are 2 point uniform arithmetic or heuristic operator. Okay, so based on so crossover will be applied on the selected chromosome by the earlier process. Okay, or the parents, those are the already selected by the earlier process. So crossover will be applied on the parents gene that are already selected from the earlier process. Now coming to the next slide, this one denote explain the 1 point crossover. So what is 1 point crossover? So 1 point crossover operator randomly select one crossover point and then copy everything before this point from this parent, and then everything after the crossover parent from the second parent. You can see that this is one of the first parent one, like this one the corresponding uh, binary pattern of the solution, and this is the corresponding binary value of and the second solution. Okay, now the user can define this one is the crossover point for the corresponding crossover operator. So what will happen, so uh, the everything after the crossover point from the parents will be shifted here, and everything after, and that means after that these will be shifted. Okay, so everything after the crossover point will be go to the parents one, and parents one after this crossover point will be moved to the second one. So you can see that corresponding offspring will be look like this. So 110 and 11011, but this characteristic will be from the second parents and this characteristic will be from the first parent. So you can see that in all offspring the characteristic from both parents will remain. Okay, so that is the crossover. And 2-point crossover, it is quite simple to understand that there will be 2 point where corresponding crossover will happen. So you can see that this is 1 point, this is one the second point. So first of all here the this part will be moved to the second parents, sorry, first parent, and this one is coming to the this one, and again it will remain same. Okay, so ultimately the corresponding offspring will look like this. And this is the corresponding uniform crossover, where there is the corresponding uniform will be decided with some kind of probability. That means how many number of crossover will be taken, like for um, two number of bit, two number of bit, or three number, or one number. You can see that this is the one is the parent one, this one is the parent two. So if the mixing ratio is 0.5, then half of the genes in the offspring will come from parent one and other half will come from the parent two. So like this we can uniform crossover will be like look like this. You can see that 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. So eight number of value moving to the this offspring one, sorry, parent one, and from there eight number of bits coming to the parent two, and ultimately we get the offspring one and offspring two. Here you can also see that 1 2 3 4 5 6 7 8. So here you can see that in each offspring eight number of bits are from original parents, and rest eight number of bits from the second parent. Similarly for offspring 2, eight number of bits are from the parent 1 and eight number of bits from the original parent 2. So this is the uniform crossover. You can select at the point 3. So if you select the point 3, so 30% will remain from the second parent and 70% from the its original. So like this you can also control the crossover value. Now coming to the arithmetic one. So in case of arithmetic one, we applied this operator for the decimal, directly on decimal number, like this. Suppose like we select the two parent, parent one and parent two. So if we use this formula like a into parent one plus a plus 1 minus a into parent two, and offspring two as the 1 minus a multiplied by parent 1 plus a into parent 2, so and then we will get the corresponding offspring, where a is the random value between 0 and 1. Okay, so it is the whiting factor to for us for the corresponding crossover operation. So you can see that this one is the point 3 parent 1, and this one is the parent 2, and if we choose the point for corresponding point 7, and if we apply the corresponding this formula, so we get the corresponding offspring value, and corresponding offspring value look like this. Okay, so this is the basically arithmetic operator, where arithmetic operator directly apply on the decimal value, not the binary value. Now coming to the heuristic operator, crossover operator, it is also applied on the directly on the uh, decimal number. Okay, no need to encode them in term of 1010, look like this. So in case of this, the uh, we need to identify first of all best parent and worst parent. Best parent, that means which have the highest fairness, and worst parent, that means which is the lowest fairness. So after that, that means best parent will be considered at the parent 1 and worst parent will be considered at the parent 2. So to generate or to crossover, after the crossover, two offspring will be generated. So offspring 1 will be generated using this equation, best parent plus r into best parent minus worst parent. That means we'll generated children around the best value. Okay, and second offspring will be best parent. Okay, so by using this formula we can also generate the corresponding uh, offspring. So these are the different crossover technique, okay, or recombination technique, where we can generate new offspring from the parents one, and in each offspring, the characteristics of the both parents will remain. That is the crossover. Okay, uh, now coming to the second one, that is the mutation. So to maintain the uh, to evolve in the changing environment, or to survive in the changing environment, some new characteristic need to be incorporated in the corresponding solution. Okay, so for that purpose mutation has been used. So mutation is a genetic operator that is used to maintain the genetic diversity from one generation to the next generation. Okay, that means some new characteristic, new gene or new chromosome are used or incorporated in the corresponding solution. Generally, the mutation or here the mutation operator is applied after the crossover, and it is also defined by the user. That means how much mutation will be taken, that is also depend on the uh, user. Okay, so so basically here the mutation operator or mutation probability basically set as very low. Okay, so like 0.01, that means we always want that um, the new characteristic will be incorporated, but it's not like that. The changing the new characteristic should not cross the original characteristic of their parents. Okay, so the probability is basically very low. Now mutation, here it is mentioned that mutation alter one or more gene value in a chromosome from its initial state. This can result in entirely new genes value being added to the gene pool. With the new gene value, the genetic algorithm may be able to arrive at better solution that was previously possible. Okay, so what is the basically if we want to observe uh, from its computational background, that means computer science. So what is the necessity of doing the mutation in case of genetic algorithm? So it is possible that for a particular optimization problem or algorithm has been stuck into the local optima. So our aim is always to reach into the global optima. So if some solution has been stuck in the local optima, so it is not possible to move out from there. So until unless new value or new characteristic has been introduced them. So for that purpose mutation is an important part for the genetic search or genetic algorithm. It helps to prevent the population from sticking at some kind at any kind local optima. Okay, so mutation is intended to prevent the search falling into the local optima of the state space. Okay, so here are the different kind of mutation operator. First one is a flip bit, and the others are boundary, non-uniform, uniform, or Gaussian. Flip bit is very widely used. So let's see what is the flip bit, and this one is the flip bit operation. Here you can see that original offspring 1 and offspring 2, which both of them are already generated from the crossover operation, and then we need to select corresponding the mutation point. So here you can see that in that we need to select like fourth point and like seventh point like this. So where there will be one, it will be converted into 0, and there will be, where there is 1, it will be converted into 0. So invert the or reverse the value, like from 0 to 1 or 1 to 0, and ultimately the muted offspring will be look like this. That means you can see that the total length of the offspring is 16, but we just muted only one or two value, 1 or 2 point, where the crossover large number of bits will be interchanged, but in case of mutation few number of bits has been changed. Okay, now coming to the others, like boundary operator. In this case, mm, in this case, the mutation operator replaces the value of the chosen gene with either upper or lower bound of that gene. Okay, so here of this obviously it can be also only used for the integer or float type of genes. And non-uniform operator, in case of non-uniform mutation operator, mm, uh, the it prevent the population from stacking at the earlier stage of the evolution, then allows the genetic algorithm to fine tune solution in the later stage of the evolution. Okay, it is also can be used for integer and float type. And there is also uniform, where the mutation are taking a mutation has been applied with some kind of probability. Okay, so the mutation operator replace the value of chosen gene with a uniform random value selected between the user the specified upper and lower bound of that gene. So and it is also can be applied for integer and float gene. And again Gaussian. So here, in case of mutation operator, some kind of Gaussian distributed random value has been generated, then it has been introduced into the corresponding solution, and obviously this value will remain between their limitation, and these are also applied for the integer and float value. So boundary, non-uniform, and uniform and Gaussian all are applied for the integer or float type of gene for type of solution, whereas the uh, flip bit that has been all applied for the binary GA, that means where the bits are encoded in term of 1010. Okay, so these are the basic operation of three operator, like selection, crossover, and mutation. Both are necessary for the genetic algorithm, so that the solution can be evolved, so that um, they can survive. Okay, and ultimately they can reach into the global optimal solution point. Now, to understand the genetic algorithm with more clarity, let's consider the same example. We want to maximize the function fx equal to x square, and the upper limit and lower limit will for the x is 31 and 0. Okay, so for that purpose we already discussed that we'll need to use 5 number of digit or 5 number of bit for the encoding purpose. Okay, so for the coding purpose, that's binary string, the length of the binary string will be 5. Fine. Okay, now let's discuss randomly generated set of solution. We consider that the population number is 4, so initially we will generate this 4 number of solution, and again then we will route roulette wheel uh, criteria or process for the selection has been applied. You can see that corresponding second string has maximum chance for the selection. How can we calculate them? So first of all, what do you do? First of all, we decode them into the corresponding uh, integer value like 13, 24, 8, 19, and we get the corresponding fitness value. Then we calculate the corresponding probability of selection, which is nothing but fi divided by summation of fj, and from there we will calculate the corresponding probability of selection, and this is the expected count. If we multiply probability with the number of n maximum number of population, so then we will get the expected count. Okay, so from there we can select the from this table you can select the corresponding genes for as parents. Now to select them, uh, so to select the parents from a pool of solution, we need to use the following process. So at the sixth step, what we have to do, we divide the range into the four beans. Okay, and size of the bean according to the relative fitness of the solution which they represent. So for this is the first solution, second, third, and fourth, and corresponding probability are already provided. This probability are calculated from the earlier table. Now we just here provide a range in between 0 to 1. So as this is the probability 0.14, so first of all we first bean or first range has been set for zero point 0 to 0.14. Next one is the as the probability of selecting is the 0.49, so we set the selection set a bean or set a range 0.14 plus 0.49, that is mean 0.63. So next one is 0.63 plus 0.06, that means 0.69, and after that 0.69 plus 0.21, that means 1. So like this, four range has been calculated or set, or we divide the range into the four subpart. 0.402, 0.14, 0.142, 0.63, 0.63, 0.69, 0.69 to 10. So how can you calculate this range? So first of all, 0 plus 0.14, next 0.14 plus 0.49, next 0.63 plus 0.06, next one 0.69 plus 0.3. Okay. Now next point is that so next point is we need to generate a random number. Suppose the random number is 0.52. So if the generated random number is 0.52 for the first time, so it will fall in this range and corresponding second parent will be selected. As the range of this second subpart is very high, so obviously selection of this selection of the string will be very high. So maximum number of random number will fall into this area. So first of all, like second solution has been selected. It has a better better chance for the selection purpose. Okay, so we chosen uh, if we choose the random number like 0.24, it will be fall into this. Okay, suppose next one is the 0.08. So if we choose a random number 0.08, obviously it will fall into the first part. So chosen string will be 01101. Okay, now coming to the next, randomly pair the numbers of the new generation. So random number generator decide for us to make the first two string together and second two string together. So for the first two string, 01101, like, and this one is the 100. Okay, and these are the random number, four number of generator: 0.08, 0.24, 0.52, 0.87. Okay, so we already discussed so if you select this 0.08, that means 01101 first, 0.24 second, 0.52 again second, and 0.87 fourth one. So here you can see the chosen string, there is third string has not been selected for this case. Okay, because the selection of the probability of selecting the third solution is low, that is 0.06. So here we can see that we have not chosen the corresponding third string or third solution. So first of all, we choose the first pair 0.01001110 from this table, from this one. Okay, and second parents are selected as 1100 1001, like this. Okay, okay. So for the first parents, first pair of string or first pair of solution, we apply 1 point crossover. Okay, so 0 is in coming to this point and 1 is coming to this point, so ultimately the solution will be 0100 and 11001. Fine. Suppose for the second pair of string we can apply the crossover point after the second digit, so you can apply that 011 will go to this and this one will be coming to this, or uniformly you can select this crossover point for this one and this one. Okay, so however, it is depend on the corresponding user. So after the crossover, the corresponding offspring will be 0100 11001 and 11011 100. Okay, so these are the basically um, offspring that has been generated after the crossover. Now coming to the mutation part. So after the mutation, some bit can be flipped or changed either from 1 to 0 or 0 to 1. But however, let's see. Uh, However, here we have not used the mutation because the number of bits are for this particular problem is already very low, that is 5. So we already apply the crossover, and if we again apply the mutation for this particular problem, it will be become similar, or value will be drastically changed. Okay, so however we have not applied the mutation operator here, but in real life problem during the simulation, obviously mutation will be applied. Okay, and that will be also defined by the corresponding user how will uh, apply, how will invert the 0 1. Okay, uh, so so by assuming that these are the mutated offspring. Okay, now next, after the mutation, what we need to do, that we again need to do reevaluate the fitness and calculate again the corresponding fitness value, and again this calculate the probability of selection and expected outcome. Here you can see that. So this one is the first iteration. After the first iteration, what we get? We get the fitness value for the second solution will be 625, and of the third selection, third value, and the third solution become 7 to 9 fitness. Okay, so in earlier classes, earlier initial cases, maximum value is 576, whereas in the after the crossover and mutation, the maximum value of fx will be become 7 to 9. That means gradually the after the first iteration, the value of x or population is going towards the optimal solution. Okay, so in after the first iteration, you can say that the for value of x, for the value of x is 27, we get the maximum value. But if we continue with this operation, if we continue this operation for few number of iteration, then we will gradually move to the its optimal point, that is 31. Okay, so what we have observed, that initial population at start, this one, like 0 1 1 0 1 1 1 0 0 1 0 0 like this, and after one cycle, new population at step 10 will be generated, and total fitness has gone from 1170 to 1754 for a single generation, and maximum fitness maximum fitness has been reached um, from 576 to 7 to 9 for after one iteration, and my total fitness has been moved from 1170 175. That means we are moving towards the global solution, and the algorithm has already come with the solution, that the third solution, that is 11011, that is this one, uh, has been this offspring as is a probable solution. Okay, but if we continue the iteration or loop has been continued, so obviously the value of x will be updated, the best value will be updated continue gradually, and we get ultimately near to the 31, which is the global solution. Okay, so coming to the conclusion part, so in this class we have studied the different GA operator like selection, crossover, mutation to create new population, and these three operators are very important to evolve with the for the evolution of the new solution, so that we can move towards the global optimal point. And after that, uh, we we have explained an example like to which is the maximization of fx equal to x square, this problem, and this has been this has been solution, this has been sorry, g has been applied for this particular problem, and it will hope this example will help you to understand the operation of GA with more clarity. Thank you all. If you have any question, please post them.